Hello everybody, especially you Carlos. Today I'll be doing the differential equation which you wanted me to explain how I got the answer to on Discord. So, the differential equation which I'm solving is y prime over y prime minus y double prime equals x. First we have to isolate the y double prime. So this, multiplying both sides by the denominator, leaves us with y prime equals y prime minus y double prime times x. Dividing both sides by x leaves us with y prime over x equals y prime minus y double prime. Subtracting both sides by y prime leaves us with y prime over x minus y prime equals negative y double prime. To get a common denominator, multiply the top and bottom by x, and at the same time I'll multiply both sides by negative 1. So this means that y double prime equals negative y prime minus y prime x over x. And now why I wanted to do that is because this is a much easier differential equation to solve, because we can let u, or any variable you want, equal to y prime, okay? Which means that u prime equals negative u minus ux over x. Multiplying by both sides by 1 over u is will make this whole thing a lot easier. So 1 over u times u prime equals u negative u minus ux over ux. And now, when we split this fraction up, this equals negative u over ux, minus minus becomes plus ux over ux. And now that equals negative 1 over x plus 1, which means that 1 over u times u prime equals negative 1 over x plus 1, which means that this is a separable differential equation. 1 over u times du equals negative 1 over x plus 1 dx. Integrating both sides leaves us with natural log absolute value of u equals, I'll put the plus t on the other side, equals negative natural log absolute value of x plus x plus c1. Doing e to the power of both sides leaves us with u equals e to the negative natural log absolute value of x plus e to the x plus c1. Okay? And now this means that u equals, this becomes 1 over e to the natural log of x, or 1 over x. So e to the x plus c1 over x. Now substituting back in for our y prime equals e to the x plus c1 over x. And now that this is an easy differential equation, dy dx equals e to the x plus c1 over x, which means that dy equals e to the x plus c1 over x dx. And now integrating both sides leaves us with y equals e to the integral of e to the x over x times e to the c1 dx. E to the c1 is just a constant, so we can bring it to the outside, meaning that y equals e to the c1 times the exponential integral of x plus c2. This is just, e to the c1 is just a constant to a constant, which is another constant, so that means that y equals c1 exponential integral of x plus c2.